Hello, welcome to the session on constructors and destructors in C++. And also we're going to talk about use case diagrams. In this video, we'll not only understand what constructor and destructors are, but also see how they work through the code examples and real world use cases. Let's begin. Before coming to the difference between the constructor and destructor with examples, I like to give how actually the constructors and destructors work. So constructors and destructors, you know that they are these special member functions in a class that manage the beginning and end of the object's life cycle. So let's take a small analogy for easy understanding. Think of it like this. When you switch on your computer, the operating system starts all the background process. Okay, this is something like a constructor, I could say. And when you shut it down, all the programs close and the memory is cleared. That's something like a destructor. So C++ does the same thing for every object you create. It sets up all the things when the object is created and also cleans them up when it is destroyed. Okay, I'm putting a small example before coming to this difference, and again the other example given here. Let's create an object of a class. For example, book B1. Something special happens automatically before even we start using B1. C++ will call a special function inside the class to set up the object. So this is called a constructor. It's something like a welcome function that prepares everything. It assigns initial values, it allocates memory, and ensures the object starts in a valid state. So the constructor is the starting point of the object's life. Now, later in the end of the program, when the object is no longer needed, maybe the function ends or the program finishes. So another special function run automatically, which is called as a destructor. Sorry, his job is to do the opposite. That's clean up whatever the constructor has set up. So it frees the memory, it closes the files, or releases any system resources the object was using. That's why we say the destructor marks the end of the object's life. So simply, I can put like this. Constructor is equivalent to the birth of an object. Destructor is equivalent to the death of an object. So these two together make sure the objects are properly created, they are used and cleaned up without we having to manually manage memory or initialization every time. Now coming to the difference given here with the constructor and destructor. Constructor is used to initialize objects when they are created. Here, destructors are used to destroy objects and release resources when they go out of the scope. Constructors are invoked automatically when an object is created. Destructors are invoked automatically when the object is destroyed. Constructor can be overloaded. That means multiple constructors with different parameters could be used. It cannot be overloaded. Only one destructor per class is allowed. Constructor has the same name as the class and no return type. Destructor has the same name as the class, preceded by a tilde symbol and no return type. It's used for memory allocation and initialization, whereas the destructor is used for memory deallocation and cleanup. Just a second. I'm sorry. Yeah. Coming to the small code given here. Let's first define a class named A. Sorry. And here the constructor also has the same name as the class A. And here there's a print function given within it. And so now What will this do is it runs automatically when an object of the class is created. So this is all the constructors. This constructor will automatically run when an object of the class is being created. So coming to the function, the program, you know that the program starts with the main function. So the object obj of class A is created here. So this constructor is automatically created and it's being called. Therefore, we get the output of this constructor is called. So now cout is executed and we are getting the output constructor is called. Then coming to then progress. So the object creation triggers the construction and then finally the program ends here. Coming to the destructor side, here you have the one difference is tilted symbol. Yes. So thus when the program reaches the end of the main function, the object obj goes out of the scope. And at that moment, the destructor function is called and therefore it prints destructor calls. Okay. So without we calling anything manually, both the constructor and the destructor handles the object's creation and destruction automatically. So constructor is called when an object is created and destructor is called when an object is destroyed. So together they define the start and the end of the object's life in the memory. Hope this is clear about, you're all clear about constructor and destructor. Coming to the use case diagram. Now let's relate this concept to a real system using a use case diagram. Use case diagram explains how users interact with the system. Constructors and destructors do not appear directly, but they are triggered by the use cases. Let's take for an example in a library management system. When the librarian selects add book, the system creates a new book object. Then the construction is called or it's invoked. When the librarian selects the remove book, the system deletes the object and the destructor is being called or invoked. So these special functions silently manage how objects are created and destroyed as users perform the actions. So this diagram, which we are going to see in the next slide, is going to map the user actions to the object lifecycle events. Here the object creation is constructor and object destruction is destructor. Here you could see the example for this, the library management system. Here in this example, the main actors are the librarian and the student, right? The librarian who adds the or removes the books. The student who borrows and returns the book. So the two are the main actors. Librarian, he can add the book or he can remove the book. Whereas a student, he can borrow or he can return the books. So when the library adds a book or librarian adds a book, the constructor is triggered to create that book object for that. When the object or when the book is removed, the destructor is triggered to delete it. During borrow or return operations, no new objects are created and the existing book objects are simply used by it. So this is a simple use case diagram to explain the constructor and the destructor. Coming to the constructor use case, let's talk about only the add book. First part. So we're going to see the constructor, how it's being applied in a real use case. Here I'm going to talk about particularly as given add book alone. The constructor ensures that every book object has valid details before being stored in the system. This first point, a mandate point to be noted. And there are three different types of constructors. Default constructor, it is used when no details are passed, for books are added with minimal information. Coming to parameterized constructor, it's used when full details are provided for the books. And copy constructor, it is actually used for duplicating the book records or to duplicate an existing book record, which means a new edition. Let's see an example for this. And here's a code for the, we are given particularly for the parameterized constructor. Let's see the step 1. Let's declare the class. Here we are defining a class named book. Okay, a class is like a blueprint for creating objects, you know very well. So inside this class, we have 3 variables. What are they? Title, author, and ID. So these are called the data members. So they store information about each book, like its name, writer, and unique ID. Coming to the step 2, that is the constructor part. You can see that the function name book is exactly the same as the class name. That's what the class name is book here. And here also we have used the book constructor name is here. The object name is book. The function name book is exactly same as the class name. And it has no return type, not even void. That's how C++ knows this as constructor. Okay. Please note this is a very important point. So here I have the book, the same name here as a book, and I have no return type, not even void function here. This particular constructor is a parameterized constructor because it accepts 3 arguments. That is book ID, book ID, yeah, okay, title T, and author A. That's what A means author, T title, and book ID. So when this constructor runs, it does 3 main things. It assigns the incoming values to the object's variable. So it ID to this book ID, title to T, author to A. Then it prints a message to confirm that the book object has been created. Something like a book added. So every time we create a book, we will get a message that the book has been successfully added. Coming to step 3, the main function. This is the starting point of the program. Here we create an object called B1 of type book. Okay. So when we pass the values 101, C++ basics, and any author name, C++ automatically looks for the constructor in the class that matches those parameters. It finds the one we defined earlier and calls it automatically. We don't have to call it ourselves. That's the beauty of the constructor here. So the constructor runs and prints the message on the screen, books added, C++ basics, as per whatever the given command. This confirms that a new book object has been successfully created and initialized. Actually, what's happening internally is, in the program starts, the object B1 is created first. The constructor, that's book, within parameters like int, string, and string runs automatically. Third, the data member's ID, title, and author are filled within the given values. A confirmation message is printed, and when the program ends, B1 is automatically destroyed. This is called as a destructor, we call. So when the librarian triggers add book, the constructor automatically runs filling in the book details. Coming to the destructor use case for remove book. Sorry. When the librarian removes a book, the object could be deleted and any memory or the file references could be cleared. That's what an example code we have given here for you. The next slide. As I told you, the symbol is a tilde symbol you have here. And this already I've explained you in the previous slide itself. So let's go to the example here. And first, as usual, let's say that you are defining the class empty book and you have the data members like title. Sorry, I'm just getting to. Yeah, the class also has two special functions inside it. That's one constructor and the one destructor. Together, they control what happens when the book object is created and when it's destroyed. So the constructor, you can identify it easily because it has the same name as the class book and it has no return type, which you have seen in the previous slide itself. So it takes one parameter, a string t, which represents the title of the book. Inside the constructor, we are assigning the title to the object's data member using the title equal to t. So when a new book object is created, the constructor automatically runs and stores the book's title inside the object. Okay. Coming to the destructor part, you can identify it by using the symbol which is given here, tilde symbol, before the name. It has no parameters and no return type. Yes, the destructor runs automatically when the object is destroyed. That is when it goes out of the scope or the program ends. So whenever an object of the class book is deleted, the destructor runs automatically and tells us which book was removed. So coming to the main function, the statement book B1 within bracket C++ basics, it creates an object. The constructor runs immediately and the title C++ basics is stored in the title variable. So after the program finishes executing the main function, the object B1 goes out of the scope and it's no longer required. So at this moment, the destructor is being called and it's being called automatically. This shows that the object has been properly destroyed and the memory is being released. So when the librarian triggers remove book, the destructor automatically called at the end of the object's lifetime. Prints books is removed and it makes the memory free or frees the resources. Okay. That's what happening in the constructor and the destructor. So coming to the object lifecycle, so I could put that in three main points. The complete lifecycle of an object could be summarized like this. It could be, for example, creation, usage, and destruction. Creation, the constructor is called where a librarian adds a book. For usage, the object performs its intended operations, that is, students borrows or returns book, whatever the object exists in the memory. Destruction, the destructor is called automatically. There's librarian removes the book. Yes. So here the same example we have given for you, whatever we have discussed. Yes, so life cycle like creation, usage, and destruction. Coming to the benefits in the real-time systems, using constructors and destructors makes the systems very much reliable, very much safe, and well organized. So these 3 points I could say, making it as reliable, safe, and organized. How it's reliable? Since every object starts with a valid data. So it's highly reliable. How it's safe? Because the memory and the resources are properly released and organized. Why it's organized? Because especially when the inheritance used, we tell about it's organized. We will see in the later slides what is inheritance in it. For example, when you take a bank account use case, I could tell that opening an account, that is constructor sets balance and ID, and for closing an account, destructor releases resources and updates the database. So this is how we have how it's being used in the real-time systems. Now coming to the constructors and destructors in the inheritance. Let's see how this works in inheritance. Yes, in C++, yeah, when a derived class object is created, the base class constructor runs first, then the derived class constructor runs. So when the object is destroyed, this happens in the reverse. So I will explain you this with an example code here. Before this, again, I like to give you a stress on this point. In C++, when a derived class object is created, the base class constructor runs first. Then only the derived class constructor runs. But when the object is destroyed, this happens in the reverse. That is, the derived class destructor runs first, and then the base class destructor runs. Yes. Yeah. So this we'll see with a detailing with an example here. Let's take the step 1. Talking about classes here. We have 2 classes here. What are they? Yes, class person and a class student. So we have person and student as 2 classes. The student class is inheriting from the person class using the syntax public person. Using the syntax public person. Okay. This means a student is also a person and it inherits all the properties and behavior of the base class. So this is correct, right? Yeah. Now coming to the base class, that's person. This is our this our basic class. That's here person here. So within that you have a constructor, and that's going to print a person constructor whenever a person object is created. And you also have a destructor, because you have a tilde symbol here, which is going to print a person destructor whenever a person object is destroyed. You should be very clear that whenever only a person object is created or destroyed, such functions will be executed. So this class defines what happens when a person object is born or when it is destroyed. Yes. Next, coming to the derived class. The derived class is student, because as I told you, you have your public person here. Now, this is our derived class, that's student. It's publicly inherits from the person class. That means whenever we create a student object, both the base class, that's a person, and the derived class, that's a student, get involved in the process. That is, the student constructor will print student constructor when a student is created, and you have tilde symbol here. So when this destructor is called, it will print student destructor when the student is destroyed. Now coming to the main function, we create a simple object named S of the class student. Now here's what happens automatically in the sequence. Let's see step by step. Because execution flow, let's see how it's being done. So when this line, that is student S, runs, C++ first calls the constructor of the base class person and the construct of the derived class student. Okay, first it calls the base class person and then only it calls the constructor of the derived class student. Why? This is because before we can have a student, we must first create a person part of that student. Every student is a person. So C++ ensures that the base class is fully constructed first. So the output during the construction is person constructor followed by student constructor. Okay. So here we follow the order from base to derived. Please note it, students, very important point is this. So first a base, then only you have your derived for constructor side. Coming to the object destructor. So when the program reaches the end of the main function, the object goes out of the scope. So it's time to destroy it now. So now C++ does in the reverse order. It first calls the derived class destructor, that is the tilde symbol with the student. Therefore, student destructor is the output now. Then only it calls the base class destructor. That's why the output is person destructor is the last output. The reason is, if we destroy the base first, the derived object would still be trying to use it. So C++ safely destroys the derived class first, and then only it goes to the destroying of base class. So the output during the destruction is first student, then followed by a person. So here I could tell that the order is from derived class to derived to the base class. Okay, so hope the final output is clear for you. So this shows the complete life cycle of a student object, how it's being built up, and then it's torn down properly. Okay, so this order is very important. Because without this order, no, you properly the program will not run. So this order ensures that every part of the object is properly managed. So just to summary, during creation, the base class sets up the common foundation first. Sorry. Then only followed the derived class adds its own features. So sorry, I will repeat again. The order goes like this. So during creation, the base class sets up the common foundation first. Then the derived class adds its own features. During the destruction, the derived class cleans up the first part. Then the base class finishes cleaning up whatever is being left. So this sequence prevents errors and resource leaks, especially in large systems where many classes are being connected. So real-time analogy, if you think about it, let's think of it like a building with two layers. The foundation is the base class and the rooms above it are the derived class. So when you build, you always create the foundation first, then build the rooms on the top. So when you demolish or destroy it, you take down the rooms first and then the foundation at the last. So C++ constructors and destructors follow exactly the same logic. Yeah. So these are the summary and key takeaways. Or the constructors run from base to derived. The destructors runs from derived to base. So you should know that this is the proper order. Inheritance does not change the automatic calling. C++ handles it all behind the scenes only. That's what we have seen the use cases of this. Coming to the summary, constructors initialize the objects, or I think you are thorough with this now. Constructors initialize the objects automatically at the creation level, and destructors cleans up the resources when objects go out of the scope. You know the order of execution also now. Constructors base first, then derived, then destructors derived first, then only base. So use case support, object lifecycle in real-time systems. You can take any examples, login, logout, or file open or file close, whatever it is. This is what the happening will be there. So constructor destructors are the foundation of OOPS concept, OOPS lifecycle management. They make systems reliable, resource efficient, and secure. They are widely applied in real-world systems, banking systems, sessions, file handling, and IoT devices. They are very much essential for inheritance, abstract class, and templates. Now let's check your understanding with a few quick questions. What is a term for a user that integrates with a system in a use case diagram? The options are object, actor, class, and system. Second, what is the relationship called when one class like student is based on the another class like person? It's polymorphism, encapsulation, inheritance, composition. What is the third question? What is the term for object's entire existence from creation by a constructor to deletion by a destructor? Is it called scope, duration, life cycle, or state? Which symbol is used to prefix a destructor name in C++? Oh, I think you could easily locate the answer. Coming to the fifth question, what is the primary real-world benefit of using a constructor according to the presentation? To delete an object when it's no longer needed, to ensure an object starts with valid initialized data, improving the reliability, to define the order of execution and the inheritance, to clean up systems resources like memory and files. Okay. Last question, which of these is a key rule for distractors mentioned in the slides? Class can have multiple distractors. Distractors can accept the parameters to customize cleanup. They are called in the same order that the constructors are called. A destructor's name is the class name prefixed with the tilde symbol. Yes, hope all your answers are correct. You can check with this. So the answers are actor, inheritance, life cycle, tilde symbol to ensure object starts with valid and initialized data, and destructor names is the class name is with the tilde symbol. Hope all your answers are right. Thank you, students. Let's meet in the next class. Bye.